Morning, and nice to see you all in person. Glad to be back with this view rather than the view I had in Zoom of nothing last week, which makes, I don't know, teaching to a sort of group of students is always a bit nicer when I can actually see your faces and get some sense of whether you're completely confused or knowing what's going on. But while we're getting started here, we do have the option here to add some things to the polling page if you would like, just to see how things went in the first week of the course. And I think with the view I have right now, maybe you can't see if anybody has voted on anything, or maybe people have just added some things and they haven't voted yet. Yeah, I guess you can't see the voting with the view that we had. But yeah, about the things that you learned during the first week. This is the kind of normal way in which we'll start off our class sessions, which is kind of just to see how it went in the previous week. And well, I suppose in the first week of the course, we covered a lot of stuff just about the course environment and kind of not a whole lot of Python content, although we did do a little bit. Sorry about that. But yeah, we did some basic commands. And it's good to see that the good coding practice about variable names also is something that you paid a little bit of attention to, because, yeah, it does make a difference. Like choosing variable names that are clear and intuitive and easy to sort of type in and use, not too long, not too short. These kind of things make a big difference when it comes to making your code easy to use and share. And we did learn also the basics of using GitHub. We will, I think, continue with that today. We'll get into more about like how does Git actually work and how to interface with GitHub in a perhaps more Git-like way during class today. So we'll also get a sense of that. But yeah, we learned some basics, and I think we're going to continue with learning some more Python basics today in our lesson, and we'll continue practicing some of the things that we learned in the first class. So we'll do some stuff with more checking on data types and defining variables, but we'll also learn a new data type today and get some practice using that, which of course will also come up in today's or the exercise for this week. I do know there were some registration issues. Some may still be ongoing, so I just want to note now that if you're still having problems getting registered, perhaps when we take the break, you could come down and let Kamyar and I know if you're still having registration problems, so we can make sure everybody who's trying to get registered to the course is registered. Yeah, I don't know. There was a little miscommunication or misunderstanding perhaps on my part about how things are working now in Sisu, and well, that led to a situation where people weren't able to late register, even though late registration was supposed to be open. So, yeah, I think this gives us some idea of what people have learned during the first week. Let's take a look. Are there any questions here? So, yeah, let me switch our view over so we can see what the questions are. So, yeah, questions, problems, afraid of getting too much new information, which would be hard to understand. Yeah, I think this is very typical, especially for the start of the course. We kind of dumped the entire course environment on you in the first week, and we're like, here, this should all make sense. And of course, it doesn't all make sense. If this microphone keeps doing this, I'll turn it off. But you'll get more practice with it as time goes on, so don't worry if not everything is totally clear to you now. It takes a couple weeks to get into it, but we really try to introduce you to programming tools that people who do this for their career are using. So we could, for instance, skip over using some of these tools, but there's a reason why we introduce them, and it just does feel a bit much in the first week. And again, don't panic about that. There's a question here about, do we get comments about the exercises, such as was the submission successful? I don't know that we would normally comment on whether or not the submission was successful, but we have asked the course assistants to give some feedback on each of the exercises. So each week We'll talk about the way in which we're going to deal with the exercises in a little bit more detail later on when we get to exercise number 2. But when we get to dealing with the exercises, you will get some feedback on what you submit. It's of course going to be, how many points you got on each problem, but also we've asked the course assistants to give a little bit of additional feedback to you as well. So like if you had a problem with a certain question, maybe they try to give you some feedback that helps you understand what you could have done differently. And then there's a comment here that you were not aware of these curly braces. So yep, in Python, I think we're going to use parentheses, we're going to use the square brackets, and we're going to use these curly braces as well. I don't know, maybe they have some other name, but that's what I've always called them. But those things, you'll get to practice with all of them. They're all different, and they do different things. So that will also be something that is often a little bit confusing, like what's the difference between the different kind of enclosing characters. So anyway, yeah, thanks for the input here about how things are going. And why don't we take a look at our lesson for today. This microphone is, I don't know why it's crackling. Let's see if it's better if I set it there. So yeah, here we are, course page. This should hopefully be familiar to you. And I hope that you were all able to kind of figure your way through the first lesson and get the first exercise completed. I know there are a couple people who are late with the exercise, but don't panic. As long as you let us know, we can be flexible, especially in the first exercise and when it's due. But we're here in week number 2, so lesson number 2, and you should see, if you go here, what we're going to talk about this week. And we're going to do some more basic stuff in Python about things like how to convert from one data type to another, but we're also going to learn a new data type itself called a Python list, and we'll learn how to use Python lists. Then we're going to explain the concept of an index value, which is a way in which you can refer to values or items that are in a list in Python. And then we're going to go into this version control discussion, and probably after the break, we'll go into version control, which is what Git is. It's a piece of software for doing version control or tracking changes to typically to software. But we'll talk about more details. Like the Git stuff in the first week was definitely kind of murky, I would say. So don't worry, we didn't expect you to kind of understand everything from how we do things with Git and GitHub from week 1. We'll go into that in more detail in this week's lesson. So we're going to start with our Python part of the lesson today. And to do this, if you're not already on the CSC notebooks and signed in there, it'd be a good time to do that. So I'm going to go ahead and do that myself. And I'll launch the Geo-Python 2023 instance. It's a good thing to kind of follow along with this part because we're going to do one thing here that's a little bit different than last week. So once this comes up, we are going to get this week's exercise or this week's lesson materials using this Git tool that's available in the CSC Notebooks environment. So I'll show you how to get the latest changes to our lesson notebooks as we get started here. So yeah, hopefully maybe you've already opened this. If you haven't, I hope there's not too long of a sort of queuing that occurs. I'm going to make this a bit bigger. Maybe that's one step too big. But yeah, last time we went into this Jupyter Lab software or application, and you might remember we had this My Work folder where we had done some stuff with Git to copy down the lesson materials. And what you should see is everything in the My Work folder sticks around week to week. It doesn't get deleted. If you had put anything in this base directory, like the one that when you launch your instance you come to, you'll notice it's gone. Only the stuff in the My Work folder gets saved in your account from week to week. And you should see, if you were here for the for the lesson last week that in the My Work folder, there is now this folder called Notebooks. Are people seeing that they have this Notebooks folder? Yeah. So what you'll notice is that when you go to Notebooks, we only have L1, and of course this is week 2, and L is short for lesson, so it makes sense that we should also have materials for lesson 2. And in order to get those, you need to navigate into the Notebooks folder and then click on this Get tool over on the left side. What you should see at that point is it takes a moment, but you'll see there are remote changes. So there are changes to this, to the documents that are in our folder. And I think, I really hope that this isn't the case, that it thinks the A Taste of Python has changed also, but we'll find out. But at this point, what you want to do is you want to click this Pull Latest Changes icon. It looks like a little cloud with an arrow that's pointing down. And if you click on that, you'll see it's pulling. And hopefully, if all goes well, you'll get a green notification down on the bottom right side that says successfully pulled. What that's doing is it's basically looking at a repository of files we have on GitHub for the lessons for each week, and it's downloading all the changes. So what that means is that if you go back to the file browser after that, you should now see you have this L2 folder that is, well, something that wasn't there before. Is there anybody who does not see the L2 folder who tried to do this? Okay. Was everybody able to get the L2 folder, or should I go through that again? I think it's described on the course page as well, so you can find it there. But if you're having problems, maybe just like raise your hand, and then I think Kamyar is here and can help. Essentially, we're going to do this each week. So when we start the lesson, our first step is going to be to download the lesson materials for that week. So now that we have it, we can go into the L2 folder, and inside there's a notebook called Python Basic Elements. And if you double click on that, that will open up the notebook we're going to use for today. Now, just for the sake of saving some space, I'm going to hide the file browser for now, so I can make this one click bigger so it's easy to see. And yeah, we can get started here with our lesson. So yeah, we're going to cover a few things today, but lists and these things called index values or indices, that's going to be the focus for today's lesson. And what we saw last time with the variables we were introduced to, we saw these whole numbers called integers. We saw these decimal numbers called floating point values or float data type. There were character strings, and then there were these Boolean values, which I don't think we did anything with Boolean, but we at least saw those 4 basic data types. There's a few different ways in Python in which you can kind of group together more than one thing, because all of those things we saw, it was like one number or one string of text or one true or false value. But of course, you often want to have a collection of values that are together. And the simplest kind of collection in Python is what's called a list. So we have an example here of, these are Finnish Meteorological Institute weather stations. So there's Helsinki Hammaria, Helsinki Kaisaniemi, Helsinki Kaivopuisto, and Helsinki Kumpula. Those are our 4 stations. And this is the format of a Python list like this. So we have the name of the variable. This would be the name of the list that we're creating, called station names. And an equal sign, which indicates we're assigning values there. Then we have this square bracket, and then comma separated values between this starting square bracket and the one at the end. And so if we just run this code cell, that's going to store our list in a variable called station names, such that if we want to, we can then print out station underscore names. And if you run that cell, you'll see that now you have these 4 values separated by commas, and they're enclosed in these square brackets. And that's what's indicating to us that this is a Python list when we look at the output. There are other types of collections, and they have sometimes different formats for how they output. I think we may see tuples at some point, but there are things that are different types, and they'll use different things, like some use parentheses and some use these kind of curly braces. But a Python list looks like this with the square brackets. And if we just wanted to confirm that we indeed created a list, we could do the type function, station names, not mains, names. And if we use the type function with our station names and then shift enter to run that cell, you should see that the data type that comes back here is indeed a Python list. So this print statement showed us the values that are in the list we created, and then this type is just telling us that the variable station names is a Python list, and that's what was assigned when we typed this in here. So just to note, I mean, I could have you type this in, but of course, like, this gets time consuming to type in Python lists by hand. So we're just running it here. You'll get to make your own lists during the exercise so you can get practice typing in the list, but it's a bit tedious to do it during the lesson, so we just kind of save time this way. So we created our first list, we checked its data type, and that's great. We have the 4 values in there, and perhaps a natural thing to wonder now is, how do we actually access individual values in the list? So a very common thing to do is create a list, and then you want to go and you want to get a single value out of the list. And if you were to do something like go here and type print station underscore names, and then add after it a pair of these square brackets, you can put a number in there, like number 1, and that will allow you to check the value of the item that you might think here is in the first position of our Python list. And when we print out station names with this square brackets and the number 1 in here, you actually see it's Helsinki Kaisaniemi that comes up, which is not the first value, but the second value in our list. So this is a sort of intentional mistake to make here. And that is to note that when you deal with lists, when you deal with collections in many programming languages, but in Python, any kind of collection, the indexing starts with 0. So when you want to refer to the first value in a list, you don't want to print station names and then put this number 1 in there to say I want the first value, but instead I'll just copy this and paste it down here. In order to get the first value in our list, we have to put in these square brackets the number 0, because the counting in the list starts at 0, so it's 0, 1, 2, 3, 4, blah, 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 instead of starting at the number 1. If you've used MATLAB, for example, I think MATLAB indexing starts at 1. Nobody used Fortran from our earlier survey, so we don't need to worry about that. Most other programming languages, C, I think Java does this, C++, they all start with 0 for the indexing. So it's a common thing, but it's a little bit unintuitive, because you might think naturally that the first value, I want to use the number 1. But this thing that we used in here, like by putting these square brackets here, we're indicating we want to take something out of our list to access a single value, and the number you put in here is actually what's called an index value, or an index number. And that is the way in which you can basically use numbers to, say, find a given value inside your list. It's a little bit weird to get used to doing things this way, so we've created this lovely I guess trick or something to help you. Bill doesn't want to get any smaller, so I guess I can stop trying to zoom out. Anyway, this is our vending machine called Bill, which basically vending machines pretty much work like Python lists, in the sense that when you go to buy something from a vending machine, you have a little keypad there, and you don't usually push like chocolate bar or whatever the thing is you want from the vending machine. You push the number on the vending machine that corresponds to the spot of the thing that you might want. Now, often it has like, maybe there's A for the rows and some number for the thing in the row, but whatever. Bill is a simple vending machine. There's 6 items, and if you wanted to, for instance, get a cookie from Bill, you would put in your money and you would push the number 1, and number 1 would give you a cookie. It's basically the same idea for Python list. When we want to find an item in a list, we basically have to use this number to tell us what the value is, or what the item is in that list. So this will take a little bit of getting used to kind of become familiar with these kind of use of index values. Every year that we've taught the course, it's been a little bit confusing. But if you can think back to the vending machine as an analogy, it's actually a pretty decent way to remember how the indexing and referencing values in a list works. So for instance here, you can see this nice taco that Bill has in slot number 3. I don't know if anybody would actually want to use this vending machine because it has like lollipops and beer and ice cream. I don't know how that vending machine actually would work. But imagine it does, and it keeps hot food hot and cold food cold. I've got to zoom back in so we can actually read this. But what you would see is if you wanted to use in Python the sort of way to get a value to print what is in index number 3 for Bill, you would just print Bill and then the square brackets 3. And what you would get back is taco. And that's because the index value for the taco is 3. So when you say, look at what's in position 3, it gives you back this taco. So we'll get more practice working with this, but I'll just include the example there of the vending machine just as a way to try and help you remember this. Whenever it comes to a new programming concept, we try to find some kind of thing you already are familiar with to help you in understanding how it works in the programming language, because the syntax sometimes can be confusing in Python, but what the code does is designed for people to be able to use it. So it's just a matter of like kind of making sure that you think and remember the way in which you're using something. So we know how now with this index value to get access to individual items inside a list. But if you want to know how many numbers or how many values are in the list, there is a function that's built in for that called len. It's short for length. And if we put in len and then station names, what this will do is it will tell us how many values are in our list. You might remember there are 4. And when you run this, you see indeed that the length or len statement comes back saying that we have 4 items in our list. That's handy. It's a very common programming thing to do, to say, create a list, fill it with values. Let's say you read in values from some data file, but you don't know how many values are in the file. You would very often use the len statement to figure out how long the list of values you just read in was. So, yeah, a few other things about using the index values. Now that we know how many values are in here, you might be tempted to say like, oh, okay, well, let's see what's the last thing in our list. And if we did print station names, use the square brackets again, and then number 4, it would, again, maybe make sense. We got 4 items in our list. Let's go to the 4th item. But actually, remember that our indexing starts at 0. So when you try to access this 4, or the value that's at index 4, you get this index error, which says list index out of range. Maybe that error message itself doesn't make that much sense to you, but essentially what it's saying is you're trying to access the 5th item in a list of 4 items, right? Because the indexing starts at 0. The last item in there would be at index number 3, and we're asking for something that doesn't actually have a value there, and you get an error message as a result. So this is something, again, that's kind of annoying. At least when I was learning to program with Python, I always thought it was kind of dumb that you could look up the length of a list, and then if you tried to access the last value, you had to subtract 1 in order to get it. The good news is that Python has a trick to make this easier. So you don't even need to know how many items you have in your list. But if we print out now station names, and inside our brackets put -1 and run this cell, we get Helsinki Kumpula. You might remember that was indeed our last item in the list. And this is a trick in Python that you can actually do reverse indexing. So if you put in -1, it starts counting from the bottom of the list and going up. So this is a great way to very quickly find out what the last value is in your list, even if you don't know. I mean, there could be 100,000 things in there, but the -1 trick will always give you the last value very quickly. That's ends up being perhaps more handy than it might seem, but it's something where, oftentimes if you read in data where you've got like dates, you want to know what was the last date I have in here. And usually things start, so the oldest things are at the start of the file, the most recent are at the end of the file, and this -1 trick is often something where you figure out what's the most recent data I have. You can also use larger numbers, so you could do like print station names and then -4. And I'll put my close parentheses there. So now we're going to go from the bottom, so -1, -2, -3, -4. So that gives us our first value in the list, which was, again, Helsinki Harmaja. And if we wanted to go one more, again, if you go to position -5, you've now gone above or like before the first value in your list, and you get an index error again saying your index is out of range. So if you try to access something that is one value longer than your list or one value above the start of the list with a negative index, you get these index errors. A lot of times that just means like you should check and see maybe you didn't define your list the way you wanted to. But these kind of index errors are usually an indication that you're trying to get a value that's not actually inside the list. If you've deleted a bunch of values from your list, for example, it can be common that you would get these kind of index errors in a code that's going through the list and doing things. So yeah, I think I didn't quite pay attention to where we were in typing this in, but essentially we just did this example of what happens if you go to -5 for the index. All right, so I've been talking for a little bit. We've introduced lists, we've introduced index values, and now we can do a poll question. I have to very quickly go here and actually make that poll question visible to you. So give me just a second to do that. Let's do this, and then we can go to the screen view here. So we have a list of cute animals. So our list is called cute_animals. It contains bunny, chick, duckling, kitten, and puppy. And the question is, which animal is at index -2? And I guess I should try to put this in some view so that not everybody sees the result right away. So let's see if I do it like this. Yeah, we'll just put it in this view for right now. So take a moment, think about it. If you were to make this list of cute animals, and maybe don't actually do that, but just think about it. If you were to go to index -2, what animal would you find? So it does look like kitten is the overwhelming choice here, and in fact, yes, that is correct. So if you remember, when we do these kind of lists, if you put in a negative index, you start from the bottom and go up. So -1 would be puppy, -2 would be kitten, and of course it's kitten because it's a course that is materials posted on the internet, and sort of kitten always win when it comes to animal cuteness. So yeah. Remember that when you start counting from the bottom of the list, you don't have the index 0. That's always going to be the first item in the list, so you always start from -1 at the bottom, then -2 would be kitten. So yes, that's basically how this kind of thing is working. And again, the negative indexing thing is a kind of handy trick to be able to use in Python. So let's make another list now. And this one is for weather station types. So this is sort of a bit unclear perhaps because we don't know which stations these are associated with, but let's not worry about that issue for the moment. We'll make this other list called station types and print it out. This should already be filled in the notebook for you. So you can just run this cell and you print it out. You see weather stations printed 4 times. One thing that's nice about Python lists is they are what's called mutable, which means that you can modify the contents of a list. So if we, for instance, wanted to change the third value in our list at index 2, instead of weather stations to be Mario graphs, we can do that, and we can print out our list again. So the way we would change a value in the list is we have to use its index to refer to what place we want to change. And in this case, we know that we want to change station names at index number 2. So again, third value. And then we say it's equal to Mario graphs, which is, I guess, some other kind of weather station, maybe something about the sea. I don't remember exactly what these station type is.
Station names and not station types.
Ah, thank you. Very good to be here in person and be corrected instead of modifying a list I didn't mean to. But yes, station types at location index 2, third value for station types, should be Mario graphs, and then let's print out station types. Once again, to see what our modified list looks like. So what you can see is, yes, in fact, the third value was modified, and so it's not a big deal in a Python list to change a value that's there. That's easy, and that's a flexible data type. As a result, that there are some data types where when you create them, you don't want to be able to modify the values that are in there, and so some of them will not be able to be changed. You can only define or delete some of these other collection types, but Python lists, no problem to modify the values that are there. Another set of cells we can just kind of run here, but let's think about it first. So we have our Python lists, and then here we're going to actually create a list with a bunch of information about the Geo-Python station. So for Geo-Python, we have its name, we have a station ID, so this is a number that's used to identify the station within the FMI system. We have a latitude and longitude, obviously not given with a lot of precision here, but we do have those values. And we have a station type, and in fact this is one of the Mario graph type stations. So if we run this, just run these 5 cells, we're going to assign these values to variables called station name, station ID, station lat, station lon, and station type. Note this is station type, whereas above we had station types, so no problem, we're not overwriting anything from before. Now imagine that we want to create a list that actually has some reference to this Geo-Python station and these different values that go along with it. We could make a variable here called station hel Geo, which is just a sort of abbreviation. And in there, we can put in these variable values we just defined. So station name, station ID, lat, lon, and type. And if we run this and print out our list that we've just created, you can see it says Helsinki Geo-Python for the first value in the list. Then we have the station ID, latitude, longitude, and the station type. So this is kind of nice. We can group all of our values together in a nice way like that. And if we check again, just to make sure we understand what's going on, we can check our station hel Geo variable type. And when you use the type function for that, you see it's a Python list. Okay, I think that makes sense. We just created the list. We should see, because we've enclosed things in square brackets, that it is a data type of a list. But if I copy this and just paste it down here, and say, let's take a look at the first item in our list using the index 0 and what its data type is. You can see it comes back as type str for a character string, which makes sense because it is the name of the station that is something enclosed in quotation marks, which means it should be a character string data type. And if I copy this and paste it in here and look at the, again, second value, index number 1, we can see it comes back as type int. So that's our station ID, so that's good. That seems to be a number value. And again, if we do the same thing for the third value in the list, which is the latitude, we get back that its type is float, meaning it's a decimal value. So this tells us something interesting about a Python list already. we know that we can have these comma separated values in here, but they don't need to be the same data type. So you can put in things that are strings and numbers all together in a Python list. You can put lists inside a Python list. You can put basically any other data type you want into a Python list, and it's a convenient way to kind of group things together. We'll see this maybe again in week 6 or so when we're dealing with larger groups of data files that we can group them together into something that's basically the equivalent of a Python list in a slightly more, I would say, slightly more advanced application. But it's great because these lists are super flexible. They're not necessarily the fastest data type to work with. So if you have really big data sets, Python lists might not make sense because they can be a little bit slow, but they're very flexible. You can change the values in there and you can store any different kind of data type you want in a list. So they are very useful because of that. Now, are there any questions or anything so far about the lists and index values and modifying things in our lists? We're going to do a little bit more stuff about how to modify lists, and then we'll show you a few different handy tools, I think, for working with lists. But yeah, okay. Seems like we're okay so far. Now, we can modify values inside our lists, like remove things, add things. We've seen how to modify a value at a single location, but if you want to basically delete something, we can use this statement called del. It's actually not just for lists. You can use it to delete any variable in Python from memory. But what we could do is we could use this del statement to remove individual values from the list, and it's one of a few different ways that you can do this kind of deleting process in Python. So actually, before we delete it, let's print our station names, because we haven't seen that in a little bit, just to remember what we have there. So we have our 4 Helsinki FMI stations here. If we wanted to delete the first one, the easy way to do that is basically to use this del statement. Notice it's not a function, so it doesn't have the parentheses. It's just del, and then we would say station names, and then we want to remove the first value in there, so we put index 0. Please remember to put index 0. If you don't put that, you will just delete the station names list entirely, which will be then kind of annoying for the rest of this lesson because we'll refer to it again. But if you do that, you don't see any output. But then if you print out what station names is, you should again now see our list of station names. What happened here? This got changed to a raw cell for some reason. And you see the 3 stations now. Just out of curiosity, this is a code cell in your notebook, right? Like when you run this, you didn't have a problem? Okay. I think maybe I just typed something and switched it while I had the cell selected. So anyway, the first value is now gone. That's how the del statement works. Again, you can use that to delete other variables as well. If we wanted to delete, station ID, we could just del station ID. We don't yet know how to use sort of ranges of index values, but you could also delete ranges of values from a list with the del statement. But there's a couple other things you can do. We don't demonstrate them here just because, to be quite honest, we don't really delete values from lists that often. It's more common to kind of delete the list entirely, but there is also something called remove, which will kind of go through a list looking for a value that you list. So like if you put, the value, like let's say we put, Helsinki Kaivopuisto in here, we could use like station names dot remove and then put in quotation marks Helsinki Kaivopuisto, and it will go looking through that list. And if it finds Helsinki Kaivopuisto, it will delete the value from the list. If it doesn't, it will give you an error message saying that it couldn't find any value like that to delete. And there's another one called pop, which basically just pops a value out of the list. But you use the index value to do that. So there's a couple options there. People have asked about this in past years during the lessons because, yeah, this is, there's a few different ways to do things oftentimes in Python. If instead of removing values, we wanted to add something to a list, there is a way to do that, where you type in the list name, so station underscore names, and then dot append. And then you put parentheses here, and we're going to append another station name, so let's put it in quotation marks. And we can do, I think we've got Helsinki Lighthouse. And we'll append a second one too. So station underscore names dot append. And what is it? The Helsinki Malmi Airfield. And I don't know whether this Helsinki Malmi Airfield station will operate anymore now that the airport's no longer going to be functional. But anyway, that's been one of the better data sources because it's been around for a while. So if we run these two cells, we're basically using the append. This is called a method that allows you to add a value to a list. So we'll run this and let's just print out our station names. Station, well, I'm off to a good start here. Station underscore names. And when we print this out, remember we lost our first value, so the Harmaja station is gone, but we now have our 3 from before, plus Lighthouse and Malmi Airfield. So our station names things can be added using this dot append. That's an easy way to do it. Again, like deleting values from a list, there are several ways in which you can add values to the list, but dot append is a handy one to know. If nothing else, it's because this dot append is a special kind of function that operates on list data types. So you can dot append a value, add something to a list, but you can't append things to other values necessarily. So we had done the station names.append thing, no problem. We've now modified it, so we've added some values there. So maybe it would be something like we want to know how many station names do we have, and we have to imagine that we don't have like 5, but some very long list where we don't want to count them. So we could make a variable here called station names length and say that one's equal to len of station names. Okay, this makes sense. We're just going to use the len function. How many values do we have in our list? And store that in a variable called station names length. And just to see it, we can print that value out. Station names length. 5, no surprise there. We started with 4, we lost 1, we added 2. You end up with 5. Okay, so what I want to demonstrate here is that the type of the data that we have here for our station names length is a data type that is an integer, right? It's a whole number. And with a whole number value, if we tried to do something like append the value 1 to it and said, let's do station names length dot append, and then the value 1, what you'll see is you get an error message here that says int object has no attribute append. So the thing that we saw with append can be used with the data type list, but it doesn't work with other data types. It doesn't really make any logical sense to try to append the number 1 to another number. Like append is normally something that's used for adding a value to a collection. So that's why you get the error message here. Basically, if you have an integer value, there is no way to append something to it. So there's no built-in functionality to do that. This is one of the things that's kind of interesting about Python, is that different data types have different kind of built-in functions that can be used to modify the values of that data type. So append is one way in which you can add a value to a list, but we'll see other examples later in the course of different data types and certain special functions that you can use to modify the values in that data type. So the attribute error here is basically just saying, yeah, there's no attribute to append a value to a number, which kind of makes sense. It's not like we're saying add them together, but it's, yeah. Okay, so some other useful things. Oftentimes, if you start working with bigger data sets and you imagine that you have them in a Python list, there is another method called count. So you can do some list.count. So we could say, for instance, station names.count. And what this will do is it will count how many times the value you list in here is found inside your list. So if we said then Helsinki Kumpula and run this, and why don't we just run it like that, what you get back is 1. So as you might remember, our list has the item Helsinki Kumpula in there 1 time, and so it searched through the list and it found one example where that value was found. If we, mistyped and put like Helsinki Kumpula instead of without the U, then of course you see it comes back as finding 0 occurrences of that. And you might think if you just said, well, let's just look for Helsinki, that's in there like 4 or 3 times, something like that. But the exact character string with just Helsinki is in there 0 times as a list item. You have to it doesn't look for part of a character string, even though our list, if we scroll back up here to the last time we printed it, you can see many of these names have Helsinki in them. It's not looking for that piece of a string, it's looking for an entire value in the list that is Helsinki, and of course it finds none in that case. Another thing that can be kind of useful with a list would be to do something called .index. So again, let's demonstrate this with our station names. And we can again put in Helsinki Kumpula. And please note that this is case sensitive, so, and I guess I do need to do .index to make this work properly. What this will do is it will find the index of a value in the list and tell you the index where you can find, in this case, the string Helsinki Kumpula in the station names list. And this comes back with index number 2, meaning it's the 3rd value in our list. And I won't scroll back up, but you can trust me if you don't recall the list contents that it is in fact the 3rd value. Again, in this case, if you misspelled or mistyped something in here and ran this, you're going to get an error message that basically is saying that it can't find any value called Helsinki Kumpula in the list. And if likewise you did a small k instead of a big K, you would get the same kind of error message because Python with character strings is case sensitive, so it sees a big K as a different character than a small k, and so it says, nope, I don't find it. There are some ways in which you can deal with the capitalization issue, but we won't deal with that just yet. I think maybe there's some point where we mention some of these things in a later lesson. All right, a few more things about about our lists. There is another method called .reverse, which is a handy one to basically take a list and reverse the order of the items inside the list. This is a helpful thing to be able to do, but I will warn you now that this is also a little bit of a dangerous thing to do sometimes. So if we do station names .reverse, just like this, you don't have to put anything inside the brackets there. And we run it, and then we print out our station names. We get back now Helsinki Malmi Airfield, Helsinki Lighthouse, Helsinki Kumpula, basically the items we had in our list now in reverse order. The reason I warn you about this one being dangerous is that it's a very common thing to say like, oh, station names equals station names.reverse. The reason you don't want to do this is because you'll notice that when you run station names.reverse, or even if you print when you run station names.reverse, you get back the value none. This method, when you run .reverse, returns a value of none. And if so, you were to then take your station names and set it equal to station names.reverse, essentially you're just deleting your list and assigning a value of none to the variable station names. So just be a bit careful with this, because there's a lot of other things where you do some kind of value equals a modified version of the value, plus something or minus something. It's a very common thing to do, but with .reverse, you have to be a bit careful. I'm sure there's a reason for doing it this way, but I've always found this to be sort of unnecessarily dangerous. But that's just me. I think it would be better for this to return the actual values in reverse order as the function output, but it doesn't, so be careful. There's also the sort method, which we can again demonstrate with our station names .sort. We'll do it the same way we did before, that we just do .sort and hit Shift Enter, and then we'll print out our station names. As you might imagine, this will sort the values in our list, and they will be sorted in alphabetical order, so that when you print them out, you now see Kaisaniemi first, Kaivo Puisto, okay, K-A-I-S, K-A-I-V, that looks like it makes sense, then Kumpula, Malmi, Airfield, and then Lighthouse, which might seem a bit unexpected that you have Helsinki M and then Helsinki L here, seemingly out of order. The thing is, with the case sensitivity in Python, capital letters come first in alphabetical order, so A through Z in capital, and then A through Z in lowercase is like in that order. So the letter L would be in the lowercase would come after M, because all the capital letters would be higher or sort of first in the alphabetical ordering, and then lowercase letters would be second. So again, this one maybe makes a little bit of a kind of counterintuitive example, but that's part of the reason why we show it to you, because some of these behaviors don't make sense right away. So it's good to see them now before you encounter it, and then you're stuck kind of wondering why these are sorted in a weird way. Just as a reminder, again, this .sort returns a value of none, so it's the same kind of deal as with .reverse, that you don't want to do station names equals station names .sort. That would just basically delete your list. All right. How are things going so far? Are we with it with these Python lists and the little methods and things like that? Of course, you get to practice in the exercise, so that's good, but yeah, there's a question.
Yeah, can we have a small break?
Yes, we're coming up to a break here, but we can do it. Why don't we get, if we can get down to this poll pausing question, sort of poll question pause, then we can take a break there. We have like a couple little things to see, but yeah, I know that the kind of capacity for sort of accepting new information is probably getting a bit limited at this point. So I'll demonstrate a couple things, and then we'll take a break, and then we'll come back and continue with stuff that's a little bit less Python coding. But yeah, the one thing I want to show you before we take the break is about making our different data types work together. So we've seen things like times when data types don't work, like if we tried to add a character string and a number together, we got these kind of error messages that came up from last week's lesson. And when we tried to append a value to an integer, we got an error message about that one. But it is often the case that you want to make strings of characters, like text and some number, work together. So how do we do that? Well, we have a few different values here that we've seen. So we have our type that we can check for station name. This is from our Kaivo Puisto, I think, example that we had before, which was a character string. We had a type for our, not site, but type for our station ID. That was a 6-number whole number thing, an integer type, and we have our type for our station latitude, or station lat. And that was a floating point, a decimal value, right? So we have those different data types, and if we try to do something here, like combine our station name and station ID, we just do station name plus station ID, you might remember that this isn't going to work because station name is a string of characters, station ID is a number, and when you add them together like this, it's like, I don't know what you want me to do. You gave me some text and a number. What am I supposed to do to combine these? And it doesn't mean you can't do that, but it just means that, as a sort of string data type plus an integer, Python won't be happy to deal with that. So that's where this data type conversion idea comes in, where sometimes to make data types work together, you have to convert from one data type to another. So for our station ID, we can do that by saying, for instance, station ID underscore str. So we'll use this to indicate we're making a character string version of our station ID. And we can use a special method here called str, a special function rather, called str to convert our station underscore ID. So str will take whatever value you put in here, and if it's possible, convert that to a character string. It will work with a lot of different data types, but it won't work like if you put a Python list in there. I don't think that's going to work. But for a station ID, it's just going to say, okay, I got a number. I'll just put quotation marks around the number, and now it's a character string. So if we run that, that's not a problem. We can check the data type. So if we do type for station underscore ID underscore str, and you run that, you see it comes back saying, yes, it is a character string. So it has converted this number into a character string. Well, what does the value actually look like? And if we print station ID str, what you'll see when you run this cell, actually it's better not to print it because it takes away the quotation marks. But if you just type in station ID str and run that cell, you'll see the quotation marks are still there. So sure enough, it is a number, but now it's wrapped in quotation marks instead of being a numerical value. It's represented differently as far as Python is concerned. So now that means if we wanted to, we could add this to another character string and everything would be perfectly fine. Okay, so as it has been made clear, this sort of capacity for absorbing more information has been reached or perhaps even surpassed. And at this point, it would be a good time to take a break. Why don't we do it like this? We can take 15 minutes. So I'll give you a good amount of time. But what I'm going to do during that 15 minutes is I will put 2 polling questions up so that you can either do them now and then go quickly try to grab a coffee or whatever, or grab a coffee and come back. But we'll continue at 10:30, and I'll put the polling questions up in the meantime so that when we continue, we can have a look at the answers to that.